When we want to do graph matching of functions and their derivatives, what some of the keys that we want to look out for are we want to match horizontal tangents with zeros. So for example, if I do find a horizontal tangent on A, the x coordinates of those should match up with zeros on another function. Okay, so in this case here, if I take a look at here and here, those zeros match up with the horizontal tangents at A. We also have non-differentiable points. So if we have non-differentiable points like this and this, they should show up as non-differentiable points on a derivative, or the derivative should not be defined at that point. So if we take a look at this graph here, the graph is not defined here and here. There's a jump, in fact, going from a positive slope to a negative slope. Okay, so in this case here, it looks like B would match that. Okay, and there's also this issue of where the derivative is positive slope or negative slope. So an example here, if I have a negative slope on a derivative, that means that the concavity of the original function should be positive. Okay, so sorry, negative slope on the derivative means negative concavity. So in this graph here, all the way to here, okay, which is those x coordinates relate here and here. Okay, looks like there's negative concavity. Here there's negative slope. Those two things seem to match. There's one more piece here that we should consider is that the derivative, if it's a polynomial, okay, the derivative is 1 degree less. So an example of that would be if I look at A, which is a cubic, and then the parabola should match that cubic function as its derivative. So looking at a few things, and we can have a lot of these things cross-reference each other. So for example, A, this is definitely A, okay, because the horizontal tangents match the zeros here. It goes from cubic to a quadratic. Okay, if we take a look at the slopes, we have here negative slope, we have negative slope, we have negative y values. That's going to be, again, negative slope here. We have positive slope in here. Okay, this is all positive y values, so it's going to be positive slope through there. In terms of the concavity, okay, we have negative concavity for that whole section here. That's going to be negative concavity. Here for that whole section, it's positive slope, so we should have all positive concavity all through that point all the way up to there, which is correct. Okay, so we have lots of cross-referencing that will justify selecting that as A. For B, it matches up with this graph here. Okay, so we already talked about this issue. Okay, this issue here of the fact that the non-differentiable points show up as undefined values on that derivative graph. We can check out our slopes here. We have positive slope, which means the derivative is positive and constant. Here we have positive slope, which means the derivative here is positive and constant. Here we have negative slope. The derivative is negative and constant because the slope value doesn't change. So this definitely is B. Okay. So taking a look at D, D matches up with this graph here. Okay, we have a fourth degree polynomial going to the third degree polynomial. We can see that the horizontal tangents here, here, and here match up with zeros here, here, and here. Okay, where we change from positive to negative slope, we should have an inflection. So here we have positive to negative. So this vertex here should indicate a point of inflection, which it does. This vertex here should match a point of inflection over here, which it does. So based on a few factors already, we can be fairly confident that that's going to be D. And then lastly, this is going to be C here. Okay, so C is going to match up with this. So we can look at horizontal tangents here, matching up with 0 here. We have a max here, a min here. Those match up with points of inflection here and here. We have negative y values, meaning we have all negative slope. We have positive y values here. That matches up with all positive slope here. And notice that the slope is tending towards 0. And we can see we're tending towards horizontal tangents at the extreme values.